Circles are a shape that comes officially from a three-dimensional cone. If you cut the cone straight across, what we're looking at is the intersection. The whole concept of conic sections are when you take a cone and you intersect it with a plane. Well, if that plane cuts straight across, think of an ice cream cone, cutting straight across, the intersection is a circle. What we're going to talk about, though, is the algebra form of that, the algebra aspect, the equation, x squared, x, etc. The standard form for the equation of a circle is written x minus h squared plus y minus k squared equals r squared. Now, h and k are particular numbers that will represent the center of your circle. R is the radius. Now, for a circle, what's nice is, of course, we're going to have to make sure that we can put our equation in the right form. And there's only two things that we really need to get from that, and that would be what is the center of this circle and what is the radius. For example, if you have an equation that is written in this form for you, x minus 3 squared plus y plus 7 squared is equal to 25. Remember the bad teenager analogy. In the house, you do the opposite. So when I am looking for my center, it's x minus what? X minus 3. So 3 is my h. H is the center of the circle, the x-coordinate of the center of the circle. K is the y-coordinate. K in this case is y minus a negative 7. So 3, negative 7 would be the center of my circle. This number represents r squared, so I have to take the square root to get my radius, and my radius would then be 5. Okay. Problem is, we don't always have an equation that's written in that form for us. Sometimes we have to rearrange the equation and put it in that form so that we can find the center and the radius fairly quickly. I put a reminder over here of the steps for something that we're going to need to do to be able to rewrite it in this form, and that is called completing the square. If you'll notice, what we really want to do with these x's is put it in a format so that it is something squared. Same thing with the y's. We want to rewrite it as parentheses of something squared. So completing the square takes your variables, or your different terms, and rewrites it and makes it what we call a perfect square. This is a perfect square because it's x minus h times x minus h. So I want to rewrite this so that I can put it in this format, and these were my steps. Step 1 is move C. So what I'm going to do is I'm going to rewrite this equation, and looking ahead, if we just peek at these, we're going to move C. C is the number that does not have the variable, so that would be this minus 3. Factor out A. What is A? A is the number in front of a squared term. In this particular case, A is 1. For the y, A is 1, so I really don't need to factor out a 1. Take half of B and square it. Well, what's B? B is always the number in front of the linear term, the x to the first power. So this B would be 6, and this B would be 4. Add equal values to both sides, so I'm going to have to add something to both sides. As I write this, where I'm going to add it is actually going to go right here, so I'm going to leave a space. And again, I'm going to leave a space. And the first step was move C, so I'm going to move this minus 3 to the other side, which would make it a positive 3. My last step that I'm aiming towards, my goal, is that when I've done all this, I will then be able to rewrite it as something squared, which is what I want my form of my equation in. All right, so let's take the steps and see what we can do here. I'm going to use a different color. Factor out A. Well, A was a 1, so I don't have to worry about that. take half of b, okay, my first b is 6. Half of that is 3. And square it. 3 squared, it's not times 2, it's 3 times 3, which would be 9. Add equal values to both sides. You learned many years ago that you want to keep the seesaw or the scale balanced. Okay, so what you do to one side of an equation, you must do to the other. If I'm going to add 9 here, then to be fair, I better add 9 here. All right? Now, the only thing is I have to do this twice sometimes. I have done steps 3 and 4 for the x's, but I need to do steps 3 and 4 for the y's. So let's start again. A, factor out A is a 1, so I don't have to do that. Take half of b, half of 4 is 2, and square it, 4. Add equal values to both sides. Add 4, add 4. Now, the reason I added 9 is because if I look at this, I can factor this now into, if you did 2 parentheses, it would look like this. X times x. What 2 numbers multiply to give me 9, but add up to 6? That would be 3 and 3. Well, and it'd be a plus and a plus. So I don't need to write x plus 3 times x plus 3. I can just write x plus 3 squared. And that's why we added the 9, so that we could do this. All right, with the y's, I have a y plus 2 times a y plus 2. Or in other words, this will factor into y plus 2 squared. Because that's step 5. Rewrite as a parenthesis squared equals 3 plus 9 is 12, plus 4 is 16. And I now have my equation written in standard form for a circle. So it looks like this. And I can now answer the 2 questions. Find the center. The center is, remember, inside the house, do the opposite. -3 for the x, -2 for the y. And since this number is r squared, I'm going to take the square root and find that r is 4. All right, let's try a couple more. And keep these from sticking. All right, x squared plus y squared minus 8x minus 4 equals 0. What's weird and different about this one, and this is how you will usually see a problem, is you have the x squared and the y squared together. That's the order that we should be writing it in. But to complete the square, I need my x with my x squared. So I'm going to do a couple things at the same time. I'm going to put the x with the x squared, but if you recall, the first step is move c. So I need to move this 4 over here. So I have an x squared, I have a minus 8x, and I'm going to leave a little space for me when I need to add something to both sides. I have a y squared, and I don't have a y. So that means I guess I don't have to complete the square for the y. I would only do that if I have a y squared and a y. So I'll leave that alone. I don't even need to leave a space now. And I'm going to add 4 to both sides. Well, when I take my next step, which is factor out A again is a 1, so I can kind of skip that. I don't need to factor out or divide everything by 1. So next step is I'm going to take half of b, which is -4, square it, and get a positive 16. Notice that the directions for that step were add equal values to both sides. You're always, when you square a number, going to have a positive. So I'll add 16. No matter what sign this is, we would be adding to both sides. Now, here's the key. When you rewrite as a parenthesis squared, because that's my step 5, rewrite as something squared. I'm going to lower this just a little bit. Okay. What goes inside, if I had factored this, I would have x and x, 4 and 4, But there would be a -4 and a -4. So what you want to do is you want to make sure you take the sign of this middle term, and that would give me an x minus 4 squared plus y squared equals 20. That is my equation in standard form for a circle, and I still need to answer the two questions, which are, what are the center and what is the radius? All right. Well, the center is positive 4. This does not have a parenthesis squared, so you could think of it as y plus 0, so that would be a 0. And then for the radius, I need to take the square root of this number. It's not always a pretty number. It's not always going to be a perfect square. The square root of 20, if you need a little help off to the side, 20 is 5 times 4, and 4 is, if you want to see the whole thing, 2 times 2 times 5. Remember, when you're taking a square root, you're looking for 2 of a kind. I see a pair of 2's, so I'm going to cross them off and write it once on the outside, and that gives me a radius of 2 square roots of 5. All right, now, let's try one more. Have some fun with this one. Oh, I still have blue. Okay, I'm going to do a few things at once. I'm going to rearrange my x's and put the x with the x squared and the y with the y squared. And I'm going to leave a space so that I can add. And I'm going to move c. So let's start this equation. I'll leave a little space, although I won't need it yet, but that's okay. I'll get into the habit of leaving that space. And negative 51. Whew. All right. The reason I'm not ready to fill that space yet is because step 2, I did step 1, which is move c. Step 2 says factor out a, and I have an a. So let's factor out a. 4 times x squared minus 6x. Leave a space. Factor out a. Here's another 4. Y squared minus 4y. Leave a space. All right. Now I have to think about this for a second. Step 3 is take half of b. A lot of times I'll word it, take half of the new b. And the reason why I would say the new b is because when you factor out a, your original b has changed. Okay? So I don't want to take half of the negative 24. I need to take half after I factored out a. So half of negative 6 is negative 3. Square it and get 9, positive 9. So I'm going to add 9. Step 4 is very specific. Add equal values. It doesn't say add the same number. Add equal values to both sides. Although I did add a 9 inside this parenthesis, on this side of the equation, I did not add 9. I added a 9, which is being multiplied by 4. So technically, on this entire side, I have just added a grand total of 36. I need to be fair and add 36 to this side. Okay? Interesting. I didn't remember what the answer was going to be, so I'm starting to see that a little bit ahead of time. All right, let's look at the y's. Half of 4 is 2. Square it and get 4. So although I need a 4 in my parenthesis, how much did I add to the entire left side? 16. I added a total of 16 on this side, so to be fair, I have to add 16 over here. All right, let's clean this up and see what we've got. Because step 5 says rewrite as parenthesis squared. Now please note that you still have that 4 there. That doesn't just disappear on you. When I rewrite this, it would be an x minus 3 squared and y minus 2 squared. Okay, let's figure this out. Negative 51 plus 36 is a negative 15. Negative 15 plus 16 is 1. Although it's not in the steps for completing the square, because I've done my completing the square, to write it in the correct standard form, I'm looking up here thinking I still have standard form, but that's on the top of this one. To put it in standard form, notice that there is no number in front of the parentheses. So I am not done yet. I cannot decide my center and radius. Well, the center is pretty obvious, but the radius is not, because I have this 4 in front of my parentheses. So I must divide everything by 4. And I get, skip down just a little, x minus 3 squared plus y minus 2 squared equals 1/4. My center is 3, 2. Do the opposite, positive 3, positive 2. The radius is the square root of 1/4. The square root of 1/4 is the same thing as the square root of 1 over the square root of 4. The square root of 1 is 1, the square root of 4 is 2, and my radius is 1/2. Woohoo, fun. And then finally, one last thing that I wanted to do. This equation is in the right form. I don't have to worry about rewriting it, so that's nice. But I wanted to show you what this looked like on a graph. What is my center of this equation, or of this circle? Well, let's see. The center, oh, I don't need an equal sign there, is the point 1, -2. What is my radius? It is the square root of 9, or 3. All right, here comes the part where Miss Springshow is not very good at graphing, so you have to excuse, because I have a sinking feeling this is going to look more like an egg and less like a circle. Center is at 1, -2. There we go. And the radius is 3. What do I do with that? I could, take a measurement and measure it all the way around. Please remember, the definition of a circle is all the points that are the exact same distance around the center. So I do know I could count 1, 2, 3 this way, and 1, 2, 3 this way. I could count 1, 2, 3 up. I'm going to sneeze. Gosh darn it. 1, 2, 3 this way. I can already tell my graph is going to look bad because look at how far these are. And then I didn't measure this very well. So it'll look like an egg no matter how hard I try. But that's a little flat. I'll try not to be too picky. But we will pretend that that looks like a circle. Okay? If you use graph paper, it will come out much better. But that would be the method that you would use to graph if you needed to for a circle. All right, that should be it. Good luck.